let's talk about the parabola. So the parabola, we know that we have a smiling face and a sad face. So a smiling face, it is when the value of a is greater than 0, and a sad face, it is when the value of a is less than 0. So here in this diagram below, we have two functions. So we have a parabola with x squared, y is equals to x squared, and a parabola with the equation y is equals to negative x squared. So what is the general equation of a parabola? So the general equation of a parabola is equals to y. It's y is equals to ax squared plus bx plus c. So in this case, in the mother graphs of parabola, which is this one, that is a smiling face, all the values are 0, b and c are 0, and then a is equals to 1. Then that's a mother graph of a parabola. Alright, so and then this one, we can see that a is less than 0, and then this one, a is greater than 0. Alright, so we have three ways in which we can rewrite the equation of a parabola. So we have this situation. So we can have a parabola that has shifted vertically downwards like this. Okay, and then it has intercepts. So the intercept, let's say, is a and b. So the equation of this parabola would be y is equals to a into x minus the x1 into x minus x2. Okay, so you can use this to find whatever that it is here. So you will find that you have this intercept and a point here. Let's say you have a point, maybe point C. So what you're going to do is that here, where there's x1, you're going to put the x value of a, and where there's x2, you're going to put the x value of b. All right. So and then to find a, you are going to put also, after substituting the negative x1, after substituting x1 and x2, you are going to substitute the point on x, on the axis and the y. Okay, for example, suppose you are given a function like this. They want you to analyze it, to find its equation, and then you are given a function like this, and then it cuts something like this, and then here you have negative 2, and then here you have positive 3. All right, so and suppose you have a point 4 mapped to 16. Yeah, let's say you have 4 mapped to 16. All right, or let's say just m mapped to n, m mapped to n. Suppose you have m mapped to n. So now they want you to find the equation of f. So finding the equation of f, you would use this, né? So you start by saying y is equals to you want to find a first. After finding a, and then everything will be sorted. So you say where there is y, you put the y value of the other point that you have. So you're going to put n here is equals to a into x. Where there's x, you put m, because it's the x value of this point. You put m minus x1. x1 will be this point, so it will be into minus 2, and then here x. For this x, you will put m again minus x2, which is positive 3. All right, and then you'll be having n is equals to a, and then whatever that m would be, depends whatever that a would be, and that m and n would be, and then you find yourself being able to solve for a. So for this case, we'll have m plus 2, m minus 3. So suppose that m and n are real numbers, and then we're going to say a is equals to n over m plus 2, m minus 3. Okay, so I just didn't want to put any number there and end up having errors. So if you have two intercepts and a point, this is the equation you use. So you substitute the coordinates of that point, you substitute them on x and y, and then on x1 and x2 you substitute the intercepts, the x values of the intercepts, and then after that you are going to get something in this form. After finding a, so then you're going to say now, oh, then y is equals to a, which is that n over blah 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 blah. Suppose it will be a number, m minus 3. Suppose this is a number, into x minus x1, plus 3 plus 2, plus 2 into x minus 3, and then you are going to multiply this out using FOIL. After using FOIL, and then you must leave it in the form ax squared plus bx plus c, because this is the form of a parabola. So out here this will be a number, and then after expanding this, and then you will multiply everything by this number, and then it will be in this form. Alright, so we have a second scenario. Alright, so we have a second scenario whereby, let's say this is a parabola. Okay, we want to know its turning points and stuff. So if we want to know the turning point of this parabola, let's say this parabola, it's something like this, okay, it's something like that. All right, so here we have a turning point TP. All right, so this turning point TP has x and y. All right, so now if we want to find a turning point, we have another form of a parabola, that is a into x plus p all squared plus q. Okay, whereby TP is a turning point, and then its x value, it's minus p mapped to q. All right, so now let's say this, for example, if they give you the equation of a parabola in this form, and then they say find the turning point, all you do, you just say, okay, x plus p is equals to 0, and then you solve for x, and then you would have x is equals to negative p. That is why here I put negative p, and then q, you take it like that. So q, it's the y value of the turning point. So another way in which you can find the turning point, so the other way in which you can find the turning point is this. You can say x is equals to minus b over 2a. So x is equals to minus b over 2a. It will give us the x value of the turning point. Okay, so this is the x value of the turning point, and then the y value of the turning point would be whatever answer that we get here, we substitute into the function that is given to us here. So we are going to say suppose this was function f, we are going to say the f of minus b over 2a, and then whatever that we get, and then it will be the y value. So you may want to know how we get this. We get this from completing the square. Okay, so if you complete the square, you will find that you will get this result. All right, so we can do this. We can say, since we have ax squared plus bx plus c, this is the function. All right, so if this is the function like this, and we are going to complete the square. Remember, when you complete the square, we must have the coefficient of x squared to be 1. So in this case, we have a. So we take out a as a common factor, and then we have x squared plus b over a x plus c over a. All right, so I'm going to deal with everything inside the brackets. So y is equals to a into, so I have x squared plus b over a x. So now I'm going to complete the square. So it says we must check the coefficient of x, multiply it by half, and square it. So what is the coefficient of x? Is b over a. Okay, multiply it by half, then it will be 1 over 2. So when it's 1 over 2, it's the same as b over 2a. Okay, and then they say I must square it, and then add it. Here I've added it and subtract it. I have subtracted it now. So I'm going to write the last one that I didn't write, plus c over a. So y is equals to a into, so now here notice that I have x squared, and here I have b over 2a all squared. So I'm going to write a smaller bracket, and I will write x plus, the plus is the sign of what is inside the bracket. What is inside the bracket is positive, so I'm going to say plus b over 2a, and then all squared. So if I expand this, it's going to give me this. Okay, so now and then here I have minus b over 2a all squared plus c over a. Right, so now, so a into now I can do this. I can multiply everything by a now. So if I multiply everything by a, okay, let me simplify this first. So if I simplify this, then I would have minus, so here will be b squared over 4a, or 4a squared. So it will be b squared over 4a squared, and then here I would have plus c over a. So if I would multiply out the whole bracket, the bigger bracket, by a, so I will have a x plus b over 2a all squared, and then if I multiply everything by a here, I will see that this a will cancel one a here, and then this a will cancel the other a. So I will have minus b squared over 4a plus c. So so now this thing, it's a hlaka-hlakano. We don't like hlaka-hlakano, so we are going to call it with one letter. So now I'm going to say now let p be equals to b over 2a, and q be equals to negative b squared over 4a plus c. So now if I do that, if I replace, it will be a into x plus p all squared, okay, plus q. That's where that equation of a parabola in this form comes from. And then now, remember I said if you want to find the x value of the turning point, you say x plus p is equals to 0, ne? So if you say x plus p is equals to 0, you take p to the other side. So remember, what is p? P is b over 2a. So it's the same as you're saying x plus b over 2a is equals to 0. So if you take that to the other side, x is equals to minus b over 2a. Hence, I said here, if you want to find the x value of the turning point, you say x is equals to minus b over 2a. This is where it comes from. Yeah, and then so for the y value of the turning point, you can use this, or you can take this and substitute it inside this, or inside the original equation that they've given you. Alright, so you can use this to do your own examples. Alright, so let me talk about the hyperbola. I'm interested in symmetry. Yes, equations of symmetry. So on a hyperbola, you have asymptotes, right? Suppose you have asymptotes, and then your asymptotes are meeting at some point. Your asymptotes are meeting. So wherever your asymptotes are missing, not missing, meeting. Let's say you have two functions like this, alright? So, and then you have two asymptotes that are meeting at 1, map to 1, for example. So we have two axes of symmetry. The other one maybe might go, the other one will go down, and the other one will go up. So as the other one goes up like that, so they will have two equations. So the one that is going down, it will have a gradient of 1, and the one that is going up will have a gradient of the one that is going up will have a gradient of 1. The one that is going down will have a gradient of minus 1. And one thing to know is that these two equations of these two lines of symmetry are perpendicular to each other. So hence, if one has a equation of 1, the other one will have a equation of -1, because if two lines are perpendicular to each other, then the products of their gradient is equals to 1. So in this case, the one that is going up will have the equation, I will name it y1, and then the one that is going down, I will call it y2. So the one that is going up will have the equation y1 is equals to x plus c1. So c1 is the constant, and then the one that is going down will have negative x plus c2. So for you to find c2 and c1, you would have to substitute the point of intersection of these lines here, which is where our asymptotes are meeting. Then you substitute it here, and then you find c2, and then you substitute it here, and then you have the equation. Okay, and if you want the equation of symmetry, or the equation of symmetry of a parabola, suppose you are given a parabola like x plus plus p all squared plus q. So you just say x plus p is equals to 0, and then you solve for p. You solve for x, and then you'll get minus p, like that. So it will depend, it can be any number there. So yeah, or you can say, suppose you are given a parabola like this with, let's say, -3 here, and then here you have 2. So you can take this distance, the whole distance, and then divide it by 2. It will give you the middle, it will give you halfway. So what are you going to do is this: you are going to say 2 minus into -3. So that is what? That is 5, isn't it? That is 5. So you're going to say 5 divided by 2. 5 divided by 2, that's what? That's 2.5. Is it 2.5? Yeah. I know it can be 2.5. So, but yeah, somewhere in the middle here, it can be 2.5. So, um, oh, you add, you don't subtract. So minus 3 plus 2, that's negative 1. Divide by 2, you're going to get what you need there. All right. So, yeah, thank you.